So hello guys and welcome to my channel. Today again I'm back with another important numericals on machine designs. And here you can see a numericals, and this numerical was once asked in 2015 spring, 2017 fall, as well as this numerical was asked in 19 spring also. And here you can see a 300 kVA 6600/400 volt 50 Hz delta and a star 3-phase core type transformer is given here. And here its respective data is given as width of high voltage winding given as 25 mm, width of low voltage winding given as 16 mm, and height of coil given as 0.5 meters, and here the length of mean turn given as 0.9 meters here, and high voltage winding turns is 830. Similarly here the width of duct between high voltage and low voltage winding is given as 15 mm. And here in this questions we have to calculate, first one is to calculate the leakage reactance of the transformers referred to high voltage side, and the second one is here, if the low voltage coil is split into two parts with one part on each side of the high voltage coil, calculate the leakage reactance referred to the high voltage side, and assume that there is a duct of 15 mm wide between high voltage winding and each part of low voltage windings. So here starting the solutions, here we have the formula. Here leakage reactance referred to primary side will be xp equal to 2 pi f mu naught Tpa square lmt upon lc and a plus b1 plus b2 upon 3, and here 2 pi f and mu naught, so 2 pi into frequency is 50 given in the questions, and similarly in place of mu naught you can write 4 pi into 10 power minus 7, and a turn is given as 830, so 830 square into lmt and lc, and here you can see here length of mean turn is given as 0.9 meters and height of coil is given as 0.5 meters. So LMT is length of mean turns and height of coil means LC. So here we have used that value. So in place of LMT upon LC, here we have 0.9 upon 0.5 into 15 into, and here A is the duct between primary and secondary, means high voltage winding and low voltage windings. Here width of duct between high voltage and low voltage winding 50 mm, and here the width of high voltage winding is given as 25 mm and width of low voltage winding is given as 16 mm here. So here 15 into 10 power minus 3 mm given in 15 mm given, plus in place of b1 here we have 25 mm, so 25 into 10 power minus 3. Similarly for b2 we have 16 mm, so 16 into 10 power minus 3 upon 3. So one calculation we will get the value of leakage reactance referred to primary side as 14 ohm. Now in the second case, the low voltage winding is divided into two parts and one on each side of high voltage, and therefore xp will be here pi of mu naught Tpa square lmt upon lc and a plus b1 plus b2 upon 6, and again here pi of is given. Similarly mu naught you can write 4 pi into 10 power minus 7, and Tpa is again 830 given, and in place of lmt or lc, here lmt is also given as 0.9 and lc is also given as here 0.5, and in place of A here we have 0.015 means 15 mm given. Similarly in place of B1 we have 25 mm given, so 0.025, plus in place of B2 we have 16 mm given, so it will be upon 6. So there is a little difference in formula. Here you can compare. Here we have 2 pi f and upon 3, but here when the low voltage winding divided into two parts, the formula the formula changes, as here the 2 is not here and here 2 is missing, and here b1 plus b2 upon 6 here is, so there is a little change in the formula. So just remember this formula, you can easily calculate all the values. So hope you enjoy the lectures. Thanks for watching, and please don't forget to subscribe to my channel. Thank you.